let's take a look. Sine. All right. So, Ralph, you're going to start off sine of 0, 0. Keep going because you're doing a great job. Yep. Yep. Try again. I'm not there yet. Yep. Yep. All right, so we sort of do the first two quadrants, then I skip to... I don't think so. Right?
3 pi over 2.
3 pi over 2 is, where is that? 270 degrees. Where is Ann on the Ferris wheel? So I went first quadrant, second quadrant, and then I skipped, right? So, all right, Rafi, that was great. Calling someone to talk us through cosine.
Root 3 over 2. Root 2 over 2. 1 over 2. 0. Negative 1 over 2. Negative root 2 over 2. Negative root 3 over 2. Negative 1 and 0.
Good. Is that all right? We feel pretty good about those? Well, I know some of you feel pretty good about those, and if you do, that's awesome. If you don't, get feeling good about that. Every night, do 5 or 10 minutes with flashcards. So those are automatic. It sort of reminds me of, remember when, what was it, like 3rd or 4th grade, you had to memorize your times tables, you needed to know what 6 times 7 was? Sure. Go halfway so we get a little bit of sunlight, but so you don't get the glare in your... That's good. Here. You will. Well, here's where, is it up there? Here it is, Rafi. You may never use what you know. It's alright, maybe you'll never use trig. But you'll definitely never use what you don't know. So if you don't know trig, you'll never use it. Right? And maybe you'll have to.
Yeah, what if you're on Jeopardy?
Exactly. So...
what is the trigonometric function of
trigonometric model. So, all right, maybe you're not walking down the street and someone's like, "Hey, quick, what's the sine of 45 degrees?" But trigonometric models actually are important. You can think about things that happen in a cyclical nature. So, for example, if we were looking at the number of hours of sunlight during the day, I think it would look something like this over the course of the year. Isn't that sort of what would happen? As a matter of fact, when would it be at its minimum? You're close, but you're not right. Why'd you say 21st?
Oh, December 21st.
December 21st, the shortest day, and we have a really special name for that. The winter solstice. Good. And then the longest day, I think that's June 21st. And that's the summer solstice. The equinoxes are actually when we have 12 and 12. 12 hours of sunlight, 12 hours of daylight. Another name for that might be the midline. That's enough out of you. Nighttime. Those are the equinoxes, and we have the vernal. Is that spring, Latin people, or French people, or language people? Vernal. Okay, good, nice. That's a good accent. And then autumnal for autumn. All right. I'm asking you. I don't know. I never took Latin. Okay, Sam says it is. All right. Also, I would think about power consumption during the course of the day, right? Maybe at the middle of the night, 4 in the morning, no one's really using much power. You're not using any electricity or heat or anything. And then you wake up and all of a sudden you want to turn on lights, you want to turn on the heat, you want everything, you're going to be using a lot of power. So probably Pico has to plan accordingly, right? They need to know when those peak times are, and they need to make sure that whatever their power grids aren't going to go out during those peak times, right? if we could share energy with people on the other side of the world, it would be great, right? When they weren't using it, we could use it. I don't know how that works, but okay. So, all right, trigonometric models are good. All right, so here it is, the tangent function. We know tangent from right triangle trig. We know tangent of an angle as... No, you don't know that. I mean, you know it because I told it. But from right triangle trigonometry, from opposite over adjacent, is that true? Our, from Sokotoa, famous yet fictional Native American mathematician. She existed just for our trigonometric knowledge. So opposite over adjacent. But if you think about Anne and her wheel, and you remember that, let's see, y is the opposite and x is the adjacent, you know that y is sine of x, and you know that x is, well, I should say sine of theta, sorry, and x is sine of, nope, I should really just do this right. Sine of theta and x is cosine of theta. So instead of saying opposite over adjacent, you can say sine of theta over cosine of theta. So the tangent ratio, if you know sine and cosine ratios, you actually know your tangent ratios. So we're going to look at the ratios, and then we're going to see if we can start thinking about what the graph would look like. Then we'll use our graphing calculator to take a look at the graph of the tangent function. Okay, so sine over cosine. Let's just go down the line. Tom, sine over cosine of 0. Sine over cosine of the angle 0. So what's the sine of 0?
Right, so that's 0, so then just be 0.
0 over
1.
Which is, you got it. Okay? So the tangent of 0 is 0. Okay. Max, the tangent of pi sixth is the sine of pi sixth over the cosine of pi sixth. And we can do a little bit of simplifying there. Yeah. 1/2 over root 3 over 2. Tom says you can multiply by the reciprocal. That's a good way of undoing the division. You could also, there are other couple ways you could simplify it. What else could you do? Multiply top and bottom by 2.
It's actually 1 over root 3.
1 over root 3. Okay, now, your Algebra 2 teacher may or may not like that. Okay? So you could either say root 3 over 3 or 1 over root 3. I'm going to put root 3 over 3, but if you write 1 over root 3, that's fine. I can live with it. Just like if you, instead of writing root 2 over 2, if you wrote 1 over root 2, that's okay. I can live with that. Okay? But don't tell your Algebra 2 teacher I told you so. Sam, question?
Why would it be root 3 over 3?
What's 1 over root 3? How do you rationalize the denominator? You always have to write root 3 over 3 because you don't know how to rationalize your denominator. Okay, so you multiply by root 3 over root 3. You get root 3 over the top. Root 3 times root 3 is root 9, but we never say root 9. We say 3. All right. All right, Elizabeth.
Root 2 over 2. Root 2 over root 2.
Which is?
1.
It is. Root 2 over root 2 is just 1. Okay. Jennifer.
Root 3 over 2 over 1.
Okay. All right. 2 root 3 over 2, which is going to simplify to root 3. Okay. Question on that, Evan?
Is it also root 3 over 1?
Yeah, you can say root 3 over 1. As a matter of fact, if you think pi sixth is 1 over root 3, pi thirds is root 3 over 1. Those are flipped. Was there another question? Someone said something, no? No. Okay. Mo, you have a tough one. What? Yeah, that's a problem. As a matter of fact, that's undefined. Okay? Put undefined. It's going to tell us a little something. Oh my goodness. Life is hard. Andrea.
Root 3 over 2 divided by negative 1/2.
Okay. think we're doing the same thing over here.
Over 2.
Yeah. Yeah, but what can we do with the 2's? Yep. Don't forget the negative. Negative root 3. Oh, I don't know. Sam's going to see a pattern, maybe. All right, let's see. Michelle? Negative 1. Corinne? Negative 1 over root 3. You can write it that way. You can write it negative root 3 over 3. Danny? Yep. All right, so we have a little bit of a pattern going on here. And actually, I think we're about ready to look at what's going to go on. Just notice for root 3 over 2, we're going to do that division by 0 again. We're going to undefined. So whenever cosine is 0, the tangent function is undefined. And so graphically, when you look at a graph and you know that a value is undefined, what sometimes happens when it's undefined on a graph? Evan?
It separates the line.
Yeah.
So you have boom and then nothing and then boom.
Yeah, what can that nothing be? There are a couple options. Right, so Evan's implying that it would be discontinuous. That's a fancy word for saying that you'd have to pick up your pencil. It would not be continuous. There would be a discontinuity there. And you've run across discontinuities in your Algebra 2 career. Yeah. It's going to be a vertical asymptote. It could be a hole or something, but in this case it's going to be a vertical asymptote. So if we go and take a look now at our tangent function, I'm going to put in tangent. I'm going to make sure that I'm in radians. And then I'm going to do something, I'm going to do zoom trig. And zoom trig actually sets up your axes so it puts tick marks at every pi halves. So it does pi halves, pi, 3 pi halves, 2 pi. And here's what the tangent function looks like. So there are those vertical asymptotes, right? That's weird. Make sure you're in radians. Make sure you're in zoom trig. And make sure you put in tangent x.
I don't think you need to be in radians to get that graph. I'm not in radians.
Yeah.
Oh, I see what you're saying. Sorry, I apologize. You're saying that it actually draws a line where the asymptote is. Yes. Some calculators do that because they try to connect the top point to the bottom point. Some of the newer calculators know not to connect it. If you want to avoid it, it's not the best way to avoid it, but it is a way. If you go to mode, if you go down, instead of doing connected, if you go to dot mode, and then you go back to your graph, it doesn't draw in the asymptotes, but it also doesn't connect the graph. It just draws dots for the graph. Okay? Oh, Sam, how can you not know where mode is? How have you been in degrees and radians at all? All right, I'm going to go back to connected and go back to my graph. All right, so here's what the tangent function looks like. What's the period of the tangent function? How often does it repeat itself? Say it loud and proud, whoever said it. Every pi. So from negative pi halves to pi halves, that's one period. It then repeats itself from pi halves to 3 pi halves. Okay? So that's interesting. I think it's interesting. Okay. That's what the tangent function looks like, and that should be sort of consistent with what we saw on the table. If you remember, let's see. Maybe I'll just grab the small one. Yep. So if you take a look, we did the tangent, and from 0 to pi halves, tangent is positive, and then there's an asymptote, it's undefined, and then from pi halves to pi, tangent is negative. Right? And if we had kept going, we would have seen that it then turns to positive, and then there's that asymptote. Okay? And remember, all students take chemistry. Tangent is positive in the third quadrant. it's negative in the second and fourth quadrants. Okay, so here it is. In the first quadrant it's positive, and in the third quadrant it's positive. And then it's negative in the second quadrant and fourth quadrant. Is that okay with the graph putting together with a table, sort of making a little bit of sense? Evan?
So if you were to make, if they were to ask for a period, you'd actually have to take two of those?
No, you'd actually say that the period for tangent function is just pi. Okay? Which actually has an interesting consequence. If we were to talk about y equals a tangent b x minus c plus d, a, c, and d are totally the same. But the b value, you know how we said before that b was equal to 2 pi over the period? In this case, for tangent, b is equal to pi over the period. Because it happens twice as fast already. Alright, so here we go. Cotangent, secant, and cosecant are all reciprocals of the other functions that we know. So not only are we adding the tangent function today, but we are now adding the reciprocals of all of the functions. So, cotangent, instead of sine over cosine, it's cosine over sine. Or another way of thinking about it is cotangent is the reciprocal, or 1 over tangent. Okay, so let's go through the reciprocal of 0. 1 over 0 is undefined. Root 3 over 3, flip it, what do you get? 3 over root 3, which, if we had to, 3 over root 3 would be 3 root 3 over 3. Oh, it's just root 3. 1, flip it. Oh, you know what? I'm wrong. Sorry. See that 1? Oh, no, that's right. Yeah, way to go. I don't know what I'm thinking. Alright, root 3, flip it. 1 over root 3, or root 3 over 3. Undefined, which was 1 over 0, becomes 0. You guys are good at this. Negative root 3. Negative 1 over root 3 is totally fine, or negative root 3 over 3. You flip negative 1 and you get negative 1. You flip negative root 3 over 3 and you get negative root 3. You flip 0 and you get undefined. So, look, it seems to me that if we were, to do insert 1 over tangent, that would be the cotangent function, and this is what the cotangent function looks like. Notice that where there were vertical asymptotes for tangent, they're now zeros. And where there were zeros for tangent, they're now vertical asymptotes. But cotangent also has a period of of pi. Okay? Alright. Secant is the same as 1 over cosine. It's the flip of 1 over cosine. Some students get this mixed up. There's secant and cosecant. And some students feel like cosecant should go with cosine. It's not that way. Sine and cosecant are reciprocals, and cosine and secant are reciprocals. So if you have to remember the S and the C pair up. Cosine pairs with secant, and sine pairs with cosecant. Alright? Alright, so let's flip cosine. What happens when you flip 1? What happens when you flip root 3 over 2? 2 over root 3, which your algebra teacher might say is 2 root 3 over 3. Now look, if you leave it as 2 over root 3, that's okay. Just don't tell your Algebra 2 teacher. Flip root 2 over 2. 2 over root 2. Your algebra teacher might make you simplify that, and you would just get root 2. Flip 1/2. 2. Flip 0. Ooh, undefined. Interesting. Flip negative 1/2. Okay. Flip negative 1/2. Flip negative root 2 over 2. You get negative root 2. Negative 2 root 3 over 3. And you flip negative 1 and you get negative 1. And if you flip 0 back down there, you get undefined.
But wait, wouldn't you be putting 0 in the denominator?
You would be.
Numerator, whatever.
No, the denominator.
No, yeah, why?
0 is 0 over 1. Flip it, you get 1 over 0. That's undefined. That won't work.
0 is 0 over 1.
Uh-huh.
Okay.
Yep, go ahead, Rafi. For 5 pi over 6, you know what I did? I just looked at pi over 6 and made it negative because it was in the other quadrant. You could have said negative 2 over root 3, but remember over here we did it now for Algebra 2 teachers. All right. So actually, there's an interesting relationship. I'm going to do the cosine of x. Hold on, I see it. Just hang on. And I'm going to do 1 over the cosine of x. And the graphs actually, I think, make sense. I mean, you can tell me. I think they do. So here's the cosine function. And if the secant function is the reciprocal, it's 1 over. That means when cosine gets small or close to 0, what happens when you do 1 over something close to 0? What's 1 over a half? 2. 1 over 0.5 is 2. What's 1 over a third? What's 1 over a tenth? What's 1 over 100? No, sorry, 1 over 100th. I don't think I said that. 1 over 100th is 100. So when cosine gets close to the x-axis, secant gets close to an asymptote. It gets really big. So it actually does sort of look like, here, cosine's bending down, secant's bending up, right? Here, cosine's bending up, secant's bending down, right? That's the 1 over. That's what it looks like in terms of a graph. Evan and then Sam, and then we're going to do a cosecant.
I understand how 2 over root 2, which you said is fine, is the same thing as 2. Like so 3 pi over 4. Pi over 4.
Pi over 4 is root 2.
I said like
2 over...
You said 2 over root 2 is acceptable, right?
Yeah.
Well, like,
So 2 over... Did I mess it up? 2 over root 2, if I want to rationalize the denominator, I get 2 root 2 over root 4, but we don't call it root 4. What do we call it? 2. The 2's go. We have root 2. I did it right.
Like, but you can have a different numerical value and it's still the same.
They're not different.
I mean, 2 divided by root 2 is not equal to...
No, 2 divided by root 2 equals root 2.
I'm saying, like, if you plug into your calculator, 2 divided by root 2.
Uh-huh. That's equal to root 2.
Why that blank?
Alright, so what happens if you have a negative secant? Because does it?
What do you want to do? Tell me. What do you mean?
Like what? I mean, like if you were to plug in your calculator negative secant, how would the graph change?
Oh, you know, we just put a negative in front of it. No. A negative in front of it just going to flip everything positive and put it below the x-axis and make everything negative, flip it above the x-axis. It's going to be a flip across the x-axis. And you knew that. Told you. Rafi, did you have a question?
About that blank, you didn't like the
Oh, is that bothering us? Oh my gosh, that's totally bothering us. What should that be?
0.
Alright. Alright. Cosecant is 1 over sine. Alright, so the rule for cosecant is you just take the reciprocal of sine. Alright, well guess how cosecant starts off? Undefined. You can't do 1 over 0. That's a problem. Say again, Tom? Or say, you sure? Alright, so we're looking up here at the sine. Flip 1/2 and you get, flip root 2 over 2 and you get root 2 or 2 over root 2. Flip root 3 over 2, 2 over root 3, or I'm going to write it like this. Again, you don't have to. I'm just being nice to our Algebra 2 teachers. Flip 1 over 0. No, why do I keep saying that? Flip 1. Why? That's the easiest one, and this is the second time I got it wrong. And I'm holding up 3 fingers. What is wrong with me? And look, I'm just going to say root 3 over 2, we already did that. 2 root 3 over 3. We already flipped root 2 over 2 and got root 2. We already flipped 1/2 and got 2. We already flipped 0 and got undefined. And I guess this one's going to be -1. And so, if you bought... No, I'm not going to wait. If you bought the story about cosine and secant, then it's not going to surprise you that sine and cosecant, which is 1 over sine, is going to actually be the same story in terms of the graph, right? It's just that everything's shifted over. But didn't we know that? Aren't sine and cosine the same except shifted over? So secant and cosecant are going to be the same except shifted over. Right? Alright, so we're going to do a few more problems without our calculator, but we did a lot. We just did a whole lot. We just introduced tangent function and understood that, and then we introduced the reciprocals of sine, cosine, and tangent. So not only do we introduce a brand new function, but we introduced reciprocals based on all those all the other 3 functions that we knew. That's a lot. So you can see that you definitely need to add to your table in terms of memorizing, or you need to come up with clever ways of doing it, like saying, oh yeah, I know that's the reciprocal, so I can just flip it. Do you want to ask a question, or 2 or 3 or 4? Mo? It's a lot. Monty? Alright. Peter? Alright. It's a ton. Alright, so let's do the best we can without our calculators. Let's go to our classwork and let's take a look at 31 and see, we're not going to get them like this, but let's see if we can at least get them like that. Alright. Say again? Yeah, put the tables away, put your calculators away. Yes, we can. We're gonna work on it. Oh. All right, humming's not helping. Oh my goodness, why? All right, we'll just do them here. All right, so let's take a look. Tangent of pi thirds. So here's what I want to do. You're not going to get it automatically, but let's hear what you're thinking about when you're trying to get tangent of pi thirds. There should be a thought process going on here. Evan?
Pi thirds is 60 degrees.
All right, so we're thinking 60 degrees, okay.
So then 60 degrees for sine is root 3 over 2, and for cosine 1 over 2, so it would be root 3 over 1.
Yeah.
I mean, yeah, root 3.
Yeah, that was great.
That was so awesome. How do you do that?
Right, I agree. So look, how does he do it? So the first thing Evan did was he knows degrees and radians. That's really helpful. And the second thing is, he didn't even think twice about what the sine and cosine of 60 degrees was. He knows them. Alright? And you can see that if you know degrees and radians and you know your sine and cosines, it actually isn't too bad. That thought process took Evan all of about 10 seconds, and I thought his explanation was great. I think everyone could follow it, and everyone was like, alright, I could do that if I knew, my sine and cosine. Give Max a nudge. Like bang him on the head or something. There we go. Thanks. That was a good look, Tom. Alright, let's do B. Evan calling someone for B.
Key.
Calling someone else, Evan.
Okay, so you know that it's 60 degrees.
Alright.
The sine is, the cosine.
Good.
Is 1 over 2.
Okay, so Sam's thinking secant's the same as 1 over cosine. See how he made the mistake, though? At first he was like sine is 1 over sine, but remember C and S goes together. So 1 over cosine. So 1 over 1/2 is 2. Awesome. All right. Go ahead and calling someone to do C, Sam.
3 times 4 is 135.
All right, so 135. So what angle is that like? 45. All right, keep going.
Sine is root 2 over 2, and cosine is negative root 2 over 2, so it's 1. Negative 1.
Yep. Awesome. All right, you see the common thread here between Evan and Sam and Corinne? Like, they're thinking about what the ratio means, they're thinking about what the angle means, and they know their sine and cosines. Let's do D, and then maybe we'll talk about 32 if we have a second. Corinne, calling someone.
Well, the cotangent is 1 over the tangent.
Oh, so if you knew C, actually, D ends up being very easy. I like it. Let's do, let's jump to J. Don't call in Sam, Elizabeth, because he just went. That would be backsies. Calling someone who hasn't gone yet.
The cosine of sine of that is negative root 3 over 2.
Hold on, things are flipping out. The sine, I don't think so.
Or is it negative 1/2?
I agree with that. Alright, it's below the x-axis, it's in the fourth quadrant, and it's negative 1/2. It's actually like a 30-degree angle in the fourth quadrant. It's 330 degrees. Alright, keep going.
And then the cosine of it?
I don't care.
Okay. So would that be over 1?
Uh-huh.
So it would be negative 1? No.
Sorry. It's this over 1, so flip it.
1. Oh. So negative 2.
Yep. Okay. So, again, there's that cosecant is based on sine, right? C and S go together. Don't make the mistake that cosecant and cosine go together. They don't. Cosecant is the flip, or the reciprocal of sine. Travis said sine's going to be negative because it's in the fourth quadrant, and it was 1/2, and then you flip it and you get negative 2. 32 is one of those questions that, like, math books and math teachers sometimes ask. And it says, hey, we're going to tell you what the cosine ratio is. Tell us what the other ratios are. And this actually goes back to right triangle trigonometry. If you have an angle theta, and you know the cosine is 4 over x, which leg is 4? Adjacent. Is that Monty? Nice work. And which side is x? The hypotenuse is x. So, if it asks for the sine, you need to find the opposite over the hypotenuse, but we don't know what the opposite is. How in the world? Oh. Tomorrow. Hey, have an awesome day. Very nice work. You did a lot today. I'm impressed.
Are we gonna have a quiz with like
on the entire thing?
It's not that, is it? It's 6-6A.
Mr. Brigade, we have